Alright guys, welcome back to our video notes 8-3 example 4, subtracting rational expressions. So here we are subtracting rational expressions with uncommon denominators, and we want to identify x values for which the expression is undefined. So remember, subtracting is exactly the same. We need a common denominator, however, we have to make sure we distribute the negative in between our rational expressions. So what would be my least common multiple of 3x and x squared? Well, 3 and 1 would have a common multiple of 3, and x squared and x, what's the highest power? X squared. So that is my least common multiple. So what do I need to multiply x squared by in order to make 3x squared? I need to multiply it by 3. What do I need to multiply 3x by to make 3x squared? I would need to multiply it by x. So 3 times 3 is 9. Subtracting 2x, I can't simplify this anymore. However, I need to state when it's undefined, 3x squared cannot equal 0. X squared cannot equal 0. X cannot equal 0. If you can do this with mental math, you don't have to show that work. All right, let's look at example B. Once again, uncommon denominators. I need to find my least common multiple of these two denominators. I can't factor them anymore, so I need to use each factor to the power that I see. So my least common multiple is 2x plus 5, 5x minus 2. So what do I need to multiply this denominator by in order to make it look like my least common multiple? It needs to be multiplied by 5x minus 2 on both the numerator and denominator. This denominator is missing 2x plus 5. So now I'm going to FOIL as I write my answer. So let's see if I can do that. 3x times 5x, 15x squared. 3x times negative 2, negative 6x. Negative 2 times negative 5, negative 10x. Negative 2 times negative 2, positive 4. Now here, remember, this is really a negative 2 distributing to each of these. Negative 2 times 2x, negative 4x. Negative 2 times negative 5, negative 10. So now let me combine like terms on my numerator to start simplifying. It's going to be 15x squared, negative 6, negative 10, and negative 4. Make negative 20x. 4 minus 10, negative 6, all over 2x plus 5, 5x minus 2. So now let me see, to simplify this rational expression, I need to see if I can factor this numerator. So let's see, is there a GCF? No GCF. 15 times negative 6 is negative 90. Negative 20, two numbers that multiply to make negative 90 yet add to make 20. If I am drawing a blank right now, so if you guys could figure this out, let me know tomorrow. So if we can factor, we should. But first, let me find where it's undefined while my brain works on that. 2x plus 5 cannot equal 0, and 5x minus 2 cannot equal 0. Remember, zero product property works with this type of example. So I have 2x cannot equal negative 5. X cannot equal negative 5 over 2 if I divide by 2 there. Adding 2, 5x cannot equal 2. Dividing by 5, x cannot equal 2/5. So this one actually has two x values where it is undefined. And here, my brain is still drawing a blank to see if we can factor that numerator. So I'm going to say no for now and just finish the problem here. All right, so we'll practice some of these in class tomorrow.